Okay guys, let's have a go at 16 then. Here we are, integral of e to the 3x times cos 2x. It's a bit like a mirror of a mirror, isn't it? Reflection of a reflection. So we're going to, when we do the parts, we'll get something e to the 3x sine 2x. Then when we do the same process again with that, we'll get back to where we started. And we piece those things together and we'll get the answer. So let's put I equals here. Let's call that V, yeah? And we'll let this be du. How's that? Okay, so let's draw our grid. So v equals cos 2x, and then du is equal to e to the 3x. So dv will be cos goes to minus sine, so it's minus 2 sine 2x, and you integrate e to the 3x as e to the 3x over the 3, isn't it? There we go. So I equals then u times v, so that's these two. So that's e to the 3x over 3 times cos 2x minus the integral of u dv dx. So that's minus 2/3, that'll be a plus 2/3 e to the 3x sine 2x dx. So that's equal to then e to the 3x over 3 cosine 2x plus 2/3 integral e to the 3x sine 2x dx. There we are, there's our subproblem then. So let's circle that. There's our subproblem here. Let's label that J. Draw a line across the page. And then do the same process. So this would be V and this would be du. Same as what we did before. Draw our grid. Like so. And let's see what we've got then, shall we? So V equals sine 2x. And then du was e to the 3x. So dv will be 2 cos 2x, and u will equal e to the 3x over the 3, isn't it, when you integrate? Okay, we've got all the constituent parts. Let's put them in then. Okay, so J equals then uv, which are these two, e to the 3x over 3 times sine 2x, that's those two, minus the integral of u dv. So that will be e to the 3x cos 2x, e to the 3x cos 2x dx. The fraction was 2/3. So I'm going to put the 2/3 at the front, because this is just back to the original integral, isn't it, the I. So we can draw a line across the page now and piece it all together, can't we? So let's go back and say, so I equals then, let's have a look, shall we? What have we got? Well, it's e to the 3x over 3 cos 2x. That's that term. Plus 2/3 of j. So let's put j in. And then we'll scroll down, give us ourselves a bit more room. Because we know what j is. J is here in the line above. So it's equal to then, what have we got? I equals e to the 3x over 3 cosine 2x plus 2/3 of j e to the 3x over 3 sine 2x minus 2/3 I, wasn't it? Because that's the original integral. Close bracket. I equals, we're putting everything together, so we need plus k at the end, haven't we? Here. So let's expand the bracket. So what have we got then? I equals this e to the 3x over 3 cos 2x. 2/3 of that will be 2/9 plus 2 over 9 e to the 3x sine 2x. And then that will be minus 4/9, agreed, of I plus k. Bring the 4/9 over to the, add to the 9/9, the 1 over here, you get 13/9. So 13 over 9i will equal, and I'm going to scale that up into 9ths. So I'm going to write 3 e to the 3x over 9 cos 2x plus 2e to the 3x sine 2x over 9 plus the k. Now we're times all the way through by 9, and I'm going to divide by 13 at the same time. So I equals, it will be 1 over e to the 3x is common, over 13, which now comes underneath. All those 9's cancel, and I have a bracket. Yeah, and I'm going to have inside 3 cos 2x plus 2 sine 2x, close bracket. That's all that taken care of. The plus constant at the end, I can just put a plus k dash because it's going to just change by a factor, because I've times by 9 and divided by 13. Okay, so the 13 came down, the e to the 3x stayed where it was. I took the e to the 3x outside the bracket, the 3 cos was here, the 2 sine is here. Alright, all the 9's cancel because I times by 9 all the way through. I rescaled my constant of integration as well. So there we go. That's 16 done then. Great. Good, let's go on to the next one.